Yeah, guys, this those are supposed to be turned in. You're not supposed to do these in class. You're supposed to do them. Okay, that makes sense. Let's go back and review this and make sure y'all understand this. Even though there's three people here, they're still going to be liable for following these procedures. A couple of y'all didn't follow the procedures when y'all turned in your lab last class. We got a couple up there. I can go ahead and grade them, but they'll probably be about 40 points deducted from them. If you want to turn them in like that, that's your call. This is a lab out of a lab book. The checkoff sheet is not the lab. The checkoff sheet was just something I gave y'all, and undoubtedly some of y'all wasn't paying attention. The lab that we were doing in last class was SF1. Okay, so there's a lab in the lab book called SF1. Okay, I got two labs that were turned in that all they had on was the inventory sheet. And that's not the lab. The lab is going to be part of the lab that you turn in, but the inventory sheet that I gave y'all out, so you wouldn't have to mark it in your lab book like I told y'all. Mark it in your lab book. I gave y'all an inventory sheet to make it more convenient. So originally, what we would do the lab is you would look at all the pictures and you'd literally have to mark them off, and then you'd turn in a big old packet at the end of the term. And it was a little hard for me to grade. Okay, everybody. Well, I know we went over the safety. Everybody know that we wear safety glasses anytime we're around the lab stations, right? We don't wear short pants or open-toed shoes in this class. We don't wear synthetic clothing in this class. Did y'all bring y'all have y'all's leather palm gloves? Yeah. Well, today is the day that we're going to start doing labs, guys. And if you didn't bring in your leather palm gloves, then I don't know what y'all going to do. Do not make any, and that was in the syllabus too that says y'all required to have that, wasn't it? Yeah, well, what's what we're going to do today? The first labs we deal is we're going to be inside that gray box right there. What are you talking about? Oh, I didn't run off any tags. I got to do that. We're not in lab right now. You need to. Not in lab right now. If we take a break, you can go down there. Okay. Short circuit tests must be performed on each circuit. We're not going to do any circuits yet. Eventually, we will. So the first thing we're going to do is we're going to the first lab that we actually do is we open up the disconnect and we make measurements inside the disconnect. And then after that, we're going to connect up our transformer. And we're going to do a lab on the transformer itself, which we'll talk about a little bit today. A light voltage test must be performed before making any circuit connections. So this is just standard procedure. Don't bet your life on the disconnect. Don't understand that. So what you do, once you disconnect the power, then the next thing you do is what? You take your voltmeter out and make sure there's no power available. Everybody understand that? So never bet your life on the disconnect when you've got these nice voltmeters that will show you if you got a problem. Now remember, AC induces voltages into everything, right? You understand? So a lot of times your meter won't measure exactly zero, but it's going to be pretty close because of what we call induced voltages or what we call ghost voltages. Verify both. Go ahead. Yeah, I gave those out. Yeah. Yes. Yeah, for some reason, I brought all the stuff for solid state over here, even the lab forms. Power must be removed from the circuit while awaiting an instructor sign off for help. Press the e-stop button to remove power. The e-stop button is pretty straightforward, right? So the gray box up in the left-hand corner, this is the disconnect for here. And you can see the big red button on there. So all you need to do is just push that in, and then that'll disconnect power. Or it's supposed to disconnect power, right? You understand that? So what do you need to do? Verify it with your what? With your meter before you get your hands in there. We got 208 up there. 208 is pretty dangerous. There's a lot higher voltages out there that's more dangerous than that, so you probably need to just get in the habit of doing it. No more than 2 conductors attached to any terminal. The problem we have is we're using banana plugs, and it gets become very critical when you're connecting these on the bottom because they have weight, right? And banana plugs are only held in by little old spring-loaded things on the side. So what happens if you put too many on there, what are they going to do? They're going to fall out, or they're going to be very easy to pull out, right? So no more than 2. And you'll find out no matter what you do, you can do it that way. And we talked about the way your house is wired, right? You take out a plug, there might be 15 plugs on there, but when you pull that plug out, it's going to be basically 4 wires, right? No matter how many plugs you got, and it's got screws on there that handles that for you. So, got to be real careful with solid strand wire, putting multiple solid strand wires under a single screw, because eventually they will work loose. That's a given. That's supposed to. That's fine, and you're supposed to use all 4 screws. You got to jump from one plug to the other, and that's what you don't use those compression things on the back. A pigtail it. Yeah, you can. That's one method that they do. They call it pigtailing, and then you use wire nuts. But how many electricians you going to see that does that? Well, not even in old neighborhoods. Yeah, because it takes a lot of times, and they still use those compression things on the back too, because you strip them out and stick them in those little slots in the back. I hate those things. Well, you can't get them out, but they'll eventually work loose too. Experiments must be performed in teams of no more than 2 students. All entries on the lab form must be done in pencil. You don't understand that. I got tired of following road maps a long time ago. Before you start a lab, what are you supposed to do? What? So yeah, that's part of it. Yeah. First of all, one thing you're going to do right off the bat, the first thing you're supposed to do is get a what? A lab form. Fill in the required information on top of the form before starting the lab. Make sure you write your name and your partner's name, first and last name, no more than 1 lab grade form at a time. Check the instructor's lab manual, so that's actually the 3rd step you're supposed to do. So all this is part of your time for that lab, right? You understand that? Check the instructor's lab manual for corrections and modifications, and document the changes in your lab manual. For some reason, people think that I've got all these corrections in my head, right? You understand? So this is why you need to document them in your what? In your lab manual. Both team partners do that. Don't say, well, Charles did it, I don't have to do it. That's not true, right? You understand that? So everybody needs to document that in their lab manual. Write your first and last name on the title page of the experiment. Do y'all understand the title page now? Okay. So when we look at our lab manual, the labs are divided into chapters. The chapter title page is not the title page for the lab. So the chapter title page is going to tell you what experiments are within that chapter. That is not the title page for the lab. I get these things turned in all the time. And then it means nothing to me because that don't tell me what lab that is. I don't know if this camera will pick this up or not. but we'll try. So this is the title page for the chapter. It's got experiment 1, 2, 3, 4, and 4. This is not the title page for the lab. I don't want this page. Keep this in your lab book. Y'all understand that? So how do I know which lab this is if you got all 4 of these on there? So when I come over here and get to the lab, it says this is the title page for the lab. This is the title of the lab. This is experiment number 1. This is the one I want turned in. This is the one I want your name written up here on the top somewhere. Your name, right? This is required for every lab. How many of y'all turned this in for the first lab? Well, there's several people that's got it in the 2D graded, and it's SS, the first lab, and there was no title page on there. So I left them in there so y'all have an opportunity to get them out and put these title pages on there. Everybody understand that? So this is the title page for the lab. This is required. If not, then I got to figure out what lab it belongs to. I've had people come up here and turn in something like this. They got their name in the top. How do I know what lab this belongs to? Well, I got to come in here and look at this page number down here. And what does LD9 mean? It means nothing to me. That don't explain what lab that is. So now I got to get my lab book, and I got to figure out what lab that runs with, and then I take 10 points off y'all's lab. Because why? To you, it seems like nothing. But what you're trying to do is you're trying to make it easy for me to grade these labs, right? You understand that? Everybody understand that? Now, you 10 seconds means nothing. But in this lab alone, I have to grade over 300 labs. Now, you take 10 seconds times 300, you're dealing with what? A lot of time, right? You understand? So this is what I expected you. I expect you to follow these procedures so I can grade these labs as fast as I can. So the title page for the lab is required. Now, when you start looking at these discussion pages, the discussion is not required. But every procedure step is required. So right here, I'd have to turn in the whole lab because every one of them is going to have check marks on it, right? Y'all understand that? So this is the procedure. But a lot of these labs will have 2 or 3 pages worth of nothing but discussions. The discussion section does not have to be turned in. Y'all understand that? Yes or no? So y'all understand the difference between the title page and the experiment and the chapter title page. I don't need the chapter title page. I need the title page for the experiment. Write your name on and not having your lab grade form at the workstation filled in with the required information at the at an instructor sign off will result in a 10-point deduction. Why? Because we got what 6 stations in here. Everybody's going to want my time at the same time. So I'm back there. I'm ready to sign off a lab, and you don't have your lab form. You say, well, let me go get one. And you come up here and you sit there, and you got everybody waiting in line, right? You understand? Waiting on me to come and sign y'all off. And here I'm waiting on you to do something you should have already done. Right? You understand? Everybody understand that? Right? I do. I teach night and days. When your team needs a lab instructor checkoff or help, one team member must write his or her name on the sign-off sheet located on the podium at the front of the lab. In the appropriate column, write your name. Place a check in the box indicating if you need help or you need a sign-off or a check. And write the number assigned to your trainer. So when I come up here, by the way, I don't keep coming back and forth. What I do is I have a little slit sheet of paper, and I go and look at the names. I write the numbers of the station, and I mark them off. So if you come up here and look at the sign-off sheet, and you sign off, and you think you're next in line, you might not be next in line. It's because I've done what? I mark those names off. Well, I write the number of your station, and that way I know where to go to, right? Everybody understand that? Everybody okay with that? So there's a space on there. Place a check mark indicating if you need a check off or help. I don't do two things at the same time. So if you need help, that's fine. Right now, we're going to let help is free. Pretty soon, help is not going to be free because everything we're going to do in this class, we're going to go over in class. And the time to ask questions is when? Is in class, right? You understand that? Okay. And like I said, to start off with, I know y'all getting in the sync of this stuff, and I'll be very lenient, but not for long. It's not going to be long before I'm going to have to start buckling down just like they would on your job, right? They have grace periods for certain things, but if your employer has to keep telling you the same thing over and over and over and over and over again, then that's when we're going to start having problems, right? The instructor will check off labs and answer questions in the order that names are placed on the sheet. So this is no grabbing Rich when he's trying to get back up here. It's just like that would make you upset if you were waiting in a line and somebody kept jumping in front of you, right? You understand? So even if you need help, if you need to ask me a question during lab, what are you going to do? You're going to write your name on the sheet. And I'm going to go down that sheet, and I'll get to you in the order that you put your name on the lab sheet. Everybody okay with that? Write the manufacturer terminal numbers, by the way. It's got num on there, but spell check spelled it right. Said that was right, but it's not. It's supposed to be numbers. On the line diagram of each circuit before beginning the construction. Let's add a little note there, too. What I want you to do is also assign line numbers and also assign cross-reference numbers. Let's see where I'm at in the procedure. It's going to be real easy to start off with because we're going to start off with how many lines? One line. And we'll start off without having any relays. We'll start off just lighting up lights. That's what we'll do to start off with. We're going to look at that a lot. Students in a team must take turns connecting circuits. Each team member must document the constructor of the circuit in the space provided on the lab form. The team member not connecting the circuit is the team supervisor and must provide manufacturer's numbers as to where connections are to be made. So you're a team. I'll see this all the time. One guy will be up here building the circuit. The other guy's down here trying to answer his questions or do something that was supposed to, or they're on a break. So I don't sign off one person. So if I come back, if you put your name up on the list and I come back there and your partner's gone, then I'll say, well, when he gets back or she gets back, you need to do what? Put your name back on the list. I don't check off anything. I don't ask questions. Remember, you're a team, right? You understand? So how does this team work? Well, what you got is you got one person connecting the circuit, and the other person is telling them what? How to connect. Y'all understand that? It runs smooth. And then every time you're going to do what? Switch up. Every circuit you're going to switch up. That gives everybody in here time. And I'm not going to say anything. I got a class taking advanced PLCs, and I had 3 people that already had intro to PLCs. And they dropped the first week because they didn't even know how to run the program. Because what did they do? Well, the instructor that taught the class did not require that. And I found out a long time ago, you got one person that wants to do everything a lot of times, and then the other person sits back and looks and don't learn anything. So I've had a conversation with them, and say you need to make them do what? Switch up. Place a check mark beside each experiment procedure step as it is completed. Y'all got these little check boxes out there, and what do you need to do? That way, when I come back and sign off, I know exactly where you're at. Everybody understand that? No, I'm talking about in the lab. Yeah, so place a check mark. So let me bring my camera back up. So when you get to procedure, yeah, when you get to procedure step, see out here on the left of every step, you got a little what? You got a little check box. So what are you going to do? Every time you do a procedure step, you're going to do what? Just check it off. And in that way, when I come back, you know where you're at. I know where I'm at, right? You understand? We don't have to stand there trying to figure out where I need to sign off at, because it's going to say right here, have the supervisor check your work. Now, don't check this off until I do what? Yeah. And then I don't have to figure out where I'm at. I know exactly where I'm supposed to be. What I'll do is I'll initial your book out here indicating that I've done what I've been past that point, right? You understand that? So every procedure has got those check marks out there, and those have to be turned in. You don't have to turn in discussions, but you do have to turn in everything that's got a mark on it, right? You understand? Because if I don't see this step right here, then that's an instructor sign-off. When I grade this, that's what I'm looking for. I'm looking to see if you got me to sign off and stuff like that. No, that's a homework lab. So your homework lab, you don't have a partner, right, Charles? You're doing those what? On your own. Yeah. Don't put your wife's name on there. That's my partner. Yeah, that's fine. Yeah, the only time we're going to be, so we got several homework labs. Those are homework labs, and you don't have a partner on that. So that's a good question. And ever have the instructor check your work procedure step, the instructor must initial your lab book indicating the steps that have been successfully completed. Skipping over any supervisor check will result in 0 on that part of the experiment. Does that make sense? Mm-hmm. So it's not one of these things where you go past, you say, well, Rich is busy, I'm going to wait on him I'm going to go ahead and do these procedures and I'll help you. No, you wait on me to get that signed off, right? You understand? Because a lot of times what you do in the next procedure steps does away with what I wanted to see. Everybody understand that? All circuits must be checked for short circuits with a student-provided ohm meter before energizing. If a fuse is blown due to not checking the circuit, then that's going to cost you 20 points. There's no reason for blowing fuses. Why? Because you're going to check before you turn power on. The instructor must perform a basic safety check and energize each circuit before circuit operation can be confirmed. So you put your name on the list. You'll say I'm ready, right, for power. You'll put a check on there. Then I'll come back there. I'll do a real fast safety check, and I'll initiate your book. But that don't mean the circuit is constructed correctly. It just means it's going to be safe to turn it on. Everybody understand that? So that first check off where it says have the supervisor energize your circuit. When it says you may energize the power switch, well, you can't do that, right? Why? Because I got the key. So every time it says then I'll come back before I turn power on. I'll look at something on the circuit. I'll show you what I'm doing later on, just to verify it's going to be safe to turn it on. It don't mean it's going to what? Work. And then once you are confident that the circuit is working as prescribed, have the lab instructor check your circuit and issue a lab book. Before the circuit is checked off, questions will be asked by the instructor to determine if you understand the circuit's operation. So you're supposed to know your circuit is working, right? You understand? Everybody okay? Trainer modules that are not part of the current connected circuit must be stored in the shelf below the lab table. All unused wiring jumpers must be hung on the bolts to the right side of the trainer. All unused wing nuts must be screwed onto a unused bolt. Everybody understand that? We talked about that a little later. So some of y'all inventoried y'all's kit. So right now I should be looking at this. And I see I've got a couple of trainers that still got modules up there, right? Y'all see that? Okay. What about that on the end? Is that way down the very? Students will not be awarded points for portions of experiment completed by team members when they are absent or tardy. When the absent or tardy team member returns, he or she must continue labs at the point at which the present team member is currently working. There is no time schedule to make up labs due to absence or tardy in this class. So what we're saying, if you're tardy or you're absent, when you come back, your partner is not going to allow you to make up the work. I won't allow that, right? So you should not, because you're absent, you shouldn't affect your partner's grade. So when you're not here, what's your partner going to do? Keep working. Right? You understand that. And when you come back, where do you start at? Where is that? Now, it would be very unusual that we have, and the labs are scaled. We scale it by two. We scale the labs by 2 labs. So that means if you miss a lab, then odds are it's not going to hurt you that. But if you're an absent a lot, then you deserve not to get a good grade in the class, right? Each team member must complete a lab grade form for each experiment. So just because you're working at a team, y'all are graded individually. Everybody understand that? So everybody's got to turn in a lab. When y'all record voltage measurements, you're going to record them on both labs, right? You're going to turn in both labs. Everybody understand that? You're going to have a lab form attached to it. You're going to have the title page on there. Lab forms are not to leave the classroom. That's the official grade. That lab form is the official grade. You take that sucker and you lose it, then you've lost your what? Your official grade, right? You understand that? Especially we've already done some work on that. Lab grade forms are not to leave the classroom. All lab grade forms must be turned in to the instructor at the end of each lab session so the student's progress can be verified. The lab grade forms will be returned to each student at the next lab session. Now, where are you going to put these? Just put them in that box over there that says what? Not ready to be graded. The questions at the end of the experiment and experiment chapter quizzes are not a team effort and must be answered individually by each student. Do not copy answers from the book or from other students. Copying will result in 0 score of all parties involved. So I mean, if you get something out of a book, it's okay, but what you need to do is you need to put it in your own words. Because if you copy it out of the book, you don't learn anything. If you take what you read and put it in your own words, then it's highly likely you'll do what? Yeah, highly likely. It's not. Questions at each of each chapter must be answered at home. So what we do in here is we do labs. When we're in lab, right? You understand. And then at the end of each lab, you have a set of questions, which some of y'all didn't turn in for FF. For System of Familiarization 1. So we got a couple of things over there in the to be graded box, and there's no title page for that lab, and there's no lab questions. Lab questions are 5 points apiece. I think there's 4 back there. That would be 20 points. You'd miss off, plus 20 points for not having the title page. So it'd be 40 points. So you take 60 on the lab if you want to leave them up there. But right now we're trying to learn my procedures, right? Some of y'all should know because this is the procedures that I use in this lab are basically what I use in all the classes. So what you do is you do labs in here. And then you answer the lab questions where? At home. Some of y'all did that, which is really good. Okay, if you're waiting on me for a sign off, then you don't have to stand up there. You can come up here and work on your lab questions if you want to do it that way. Is that okay? So the way the lab book is set up, it's set up in chapters. And it don't have the page numbers are weird because once you get into the system familiarization, it's going to be a step one, it's going to be the first page, and it's going to go to whatever's on it. Right? Then you go into another chapter, and it starts off with 1 again. So the lab book is real hard for us to say, okay, let's turn to this page because we have to give you the chapter number. Okay. And then at the end of each chapter is a chapter quiz. And this is why we don't have online quizzes on Blackboard, because the quizzes, we run the lectures like we do the labs, right? You understand? So those are going to be attached to the last lab. Let's go ahead and finish this. And it says also, when you look at my lab book, if it does not say skip a question, so you got discussions and everything in that lab we've talked about, but some of the circuits we're going to skip over. Okay, y'all understand that? But you're still responsible for answering the questions if it don't say what in my lab book. Skip. And between the discussion in the lab and also what we talk about in class, you should be able to answer those, or I thought you could. So it says this includes questions for circuits and experiments that were not constructed. And I hear that all the time. It says, well, we didn't build that circuit. And then I say, well, did it tell you to skip the question? Once you complete an experiment, and this is where we had problems too, once we complete an experiment, so what you're going to do is you're going to turn in a packet at the end when you turn it in. Staple the lab grade form where? In the upper left-hand corner. Why I did that? So I'm right-handed, so I write with my right hand. So when I turn my pages, I turn them like this. Well, I had a guy in my class stapled it in the upper right-hand corner. And you wouldn't believe how much trouble it is. You got 100 labs, and everybody's doing it like that, and this guy's doing it like this. So he got his own lab procedure. In the upper left-hand corner to the front of the experiment pages, right, and place it in the box labeled what? Motor control labs to be graded. This box is located on the lab bench at the front of the lab. Do not forget to write your name in the space provided in the lab grade form, which should already be done. Also, make sure you write your name on the top of the experiment title page. Include the front experiment page, title page, that has the title of and experiment number. The first few discussion pages do not need to be turned in for grading. All pages that contain instructor sign-off or student written information must be included. Make sure the experiment pages are stapled in the correct order. That bothers me too, guys. You know, you're looking at a key and somebody has the pages all stapled together. That gets me too. And most of y'all can count, right? So y'all know how to put them in order according to their page numbers. Make sure the experiment pages are stapled in the correct order, lowest page number to the highest. Do not staple multiple experiments together. I get that all the time too. One experiment, lab grade form, or y'all understand that? Are you okay? Completed experiments that require the construction of a circuit must be turned in with all experiment questions answered before the beginning of the next class. So I've seen people come in here, they'll try to do labs while I'm up here lecturing. Next class meeting, after the last circuit experiment has been signed off. And this is what we told y'all. So what we do is, I don't want you to answer lab questions in lab. So what do? Well, when you finish the last circuit, when you construct the last circuit or do the last thing, I'm going to put a date that it's due, and it's going to be when? The next class. So, everybody okay? The due date for the homework experiments will be posted on Blackboard course calendar. So we have 2 that's due today. They were on the calendar, right? Hopefully. I know they were. The experiment grade will be reduced by 10 points for each weekday the labs are late. Everybody understand that? Yes or no? Lab chapter quizzes must be completed and stapled to the last experiment. The problem we have with chapter quizzes is that a lot of times the chapter quiz is on the last page of the lab. But if you try to turn the chapter quiz in separately, then you're going to have to tear off a section of the lab, right? Understand? Now, chapter quizzes are graded differently or not as part of the lab. They've got their own thing in the grade book if you listen to that. So if you look at the grade book, it says like SF1, it's got like SF1, 2, 3, and then it's got called chapter quiz. So the chapter quizzes are graded individually, but you cannot separate them in terms of themselves. Lab chapter quizzes must be completed and stapled to the what? To the last experiment completed in each lab chapter. Lab chapter quizzes will be graded separately from the experiment. Make sure you write your name at the top of each chapter quiz that contains the first quiz question. Do not attach a lab grade form to the chapter quiz. Now, toward the end of the term, what some students do is they'll, if they can't get to the lab, they'll turn in the quizzes, which is okay. But these are not labs. These are not labs. These are quizzes. They do not get a lab grade for. Everybody understand that? But you better put your name on it. Also, what I do when I give your labs back to you, I keep the quizzes for obvious reasons, because if I gave the corrected quizzes back, then eventually everybody would have all the answers right. You understand that? So what I do is I take the chapter quizzes off, and plus the chapter quizzes are part of our student learner outcomes. This is one of so in our program we have certain classes that are basically part of our accreditation, and these are classes that everybody in the program has to take. So everybody in ILT has to take what? Motor controls. So motor controls is a SLO or student learner outcome class. And what that means is that we got to keep a lot of stuff that we have to provide to the people that come in to the campus. We have to make it available. Sometimes they don't check it. As far as our accreditation. And part of our SLOs is all those lab chapter quizzes. So we have to put them in a big old binder. Couldn't believe all the stuff you got to do. So what you're going to do is when you get to the chapter quiz, what are you going to do? You're just going to staple it to what? The last lab. Completed labs are to remain in the instructor's possession during the entire term. The completed labs will be returned to the student during the first week of the next semester upon request of the student. Labs that are not claimed during this time period will be destroyed. So you'll get your labs back. Everybody gets their labs back if you want them. If you don't want them, then I'll shred them. Because all I have to keep is lab grade for them. That's one way we can give them back. So what we're going to do and make sure we understand when you look at your chapters, every chapter has an abbreviation. Well, what does abbreviation come from? Have y'all got y'all's lab books? Sorry, yes, beside the page number, you're right. So right now, when you turn in your lab, y'all was working in the safety section. Well, if you look at the safety section, it says X on the page. So that's the lab abbreviation. It's also, the lab abbreviation is also right here. So the labs that we're going to be doing, so safety is abbreviated what? As LDGC. So these are the abbreviations that goes on the lab form. Then what you do next is you don't put the page number, you put the what? The number of the experiment. I get this all the time in the abbreviation, the MOC1, the page number 1, but I don't need the 1, right? All I need is MOC. And then this is the experiment number, and this is the title of the experiment. Where do you get the title of the experiment at? Off the title page. Okay. This is another thing that gives people problems. I don't care what time you start, and I don't care what time you end down here. All I want to know is the number of hours that you worked on it that day. Round it to the what? Different there's half hour. Is that hard? I don't need the time you started, which you need to keep up with it. I don't need the time you started. I don't need the time you ended. And of course, why do we do this for? Just to help us trend the classes, right? Everybody okay? Next is, this is where you're going to keep up with who built the circuit. You're going to keep up, you're going to put the figure number that is. And then when I sign a circuit off, what I'm going to do is I'm going to do two things. I'm going to initial your lab book, and I'm also going to initial the lab form, indicating that that circuit has been signed off. This is where I actually start grading at right here. So right here, paperwork, I put an initial out there, indicating that you had a problem, and then when I grade it, I'll put what deduction I'll make over here. Every lab is worth 100 points. And I found out that works out great because some labs they're very short and it's hard to get made bad on them. Some labs are long. I start deducting points, and when I get down to 100, and that's it for that. That makes sense. Then next, this shows you how you're going to be graded. This is how I deduct. Gave y'all. How many of y'all get all this stuff from an email? So you know how you're graded, you know how to deduct the points, and these are the labs we're going to do. Today we have two labs to do. Which two are due? S1 and S2. And then Tuesday we're going to have three labs to do, homework labs to do, 3, 2, and 3. So we're going to do S3, S2, and S3. And then lab 1 we're going to do in class. So lab 1 we've already done. So what we're going to do today is, once we get over this, is we're going to do these two guys right here. Power source 1 and 2. What we're going to work on. By the way, there's really no due dates for lab. What I found out a long time ago is some people do labs faster, some people it moves around. So you turn in the labs when you get through with them, right? You understand, but you got to understand that you're graded on quality, you're graded on what? Quantity. I had a student one time. We had 14 labs doing in a class, and he turned in 3, and he didn't understand why he failed lab. Hey, the ones he turned in, he made in the 80s, but you know. So that's the labs, guys. Y'all got any questions on this? You know, I went over the lab procedure. I know I started on it. And I go by this lab procedure. I mean, I got to, because like I said, you know, I'll bring them in here one day and show you all the labs in this class. You know, we got 12 people. And how many labs do we have, are we trying to do? And some of y'all won't get through. Some of y'all will. Some of y'all won't get through. I've never taught the class where everybody in the class gets through. Everybody's going to do this lab because it's an SLO lab. Okay. So that means when we get to reversers, what we'll do is, no matter where you're at in the list up here, all we'll do when we get to reversers is that everybody will do this. So that's our SLOs. And then everybody's going to have to do at least one timer lab. So these two circuits right here, these are required because those are part of our outcomes. Everybody okay? Y'all got any questions about the lab procedures? What do you mean? Not homework labs are homework labs. They're going to have due dates. I understand that. So what I do on your lab form is when you start wiring circuits, So when you start wiring circuits, what I'll do is up here I'll put what day I signed off the last circuit in there. And here I'm going to put the what? Due date. And the due date will be the next class. Homework labs are homework labs. They were put out last class, right? You understand that they were due to when today. And then if you don't turn them in today, you lose 10 points per day. I know where I'm located at, right? So my office is over in the hall building. So you can always come over there and turn it in. But and weekends are basically free because you can't turn them in during those times. But 10 points every day is late. That's that due date. I mean, if you can't turn them in on time, well, then that's not the day. Like the classes, that's why it says the next time the class meets. It don't say the next time it meets, right? Like next Thursday. Y'all know what next Thursday is? What's next Thursday, Bobby? Awards. Yeah, and the awards runs from classes are dismissed from 9 to 12:30. So we'll have to look at that. So that's an hour. So I'll be back over here. So y'all need to come in, but y'all don't have to come in to what? 12:30. Yeah, we during the spring semester we have what we call awards day, awards and recognition day is what they do it. Isn't it? Well, we do, but we've only got an hour. Class won't start to 12:30. I'm required to meet y'all, by the way. This class goes to 1:30, so I can't. I'm gonna come over here. It's whether you come or not. If you don't come, I count you absent. That's up to you. That's right, but we won't. Classes are dismissed next Thursday from 9 to 12:30, and of course this class starts at what? I don't know what you mean studying. Studying is what you do. That's life. We had that. Yes, right. If you want to be counted present, it's up to you. We will do something in class, but it will be recorded. Well, I don't either. So, Al, got any questions? Any other questions to that? According to that, your question, you okay? What's that? No, when I come up here, I'll show 'em. So here's a figure that y'all gonna wire. Right here it says what? Figure 9. Can you see that? Okay. So the figure number will be the number of the circuit that you construct. Okay. Okay. Any more questions? We ain't got there yet. We're gonna do PS. We're gonna do power supply PS1 and PS2 today, or we're gonna work on them. Everybody okay? If we can get there. Any questions? Any more questions about the lab procedure? Everybody know what time the class starts, right? Because a lot of y'all have been marked absent, and somebody needs to tell me if they're here or not here. So starts at 9. I'm laughing because we were in Germany, and you know what 9 means in German? No, yeah. So we had one of our instructors said they asked him what time does class start, and he said 9, and we said okay, we're not having class. They gave us. We asked them that, but I'm the kind of person that if I don't think I'll ever use something, I don't. Nancy probably knows. She really got into it over there. She tried to learn a lot of German words, but I didn't care. I'm under the I'm the kind of person that if I don't think I'm gonna ever see you again, and you give me your name, I shake your hand. By the time I let go, I don't know who the heck you are. That's just my trait. I guess because I got so much junk floating around in my head. So what we're going to do today is we're going to look at our power supply. Let me jump. So let's see. Which we're going to work on PS1 and PS2 at least. Yeah. So one of what we're going to do is we're going to open up the disconnect. I'll show you how that works in a minute. We'll go up there and look at the lab. And another thing we're going to do is we're going to wire our transformer. By the way, once the transformer is wired, then we'll leave that module up on the board the whole time. So that's the only module that's going to be allowed to stay on the trainer the whole semester once it's wired. Everybody understand? Okay. Okay, so what we're dealing with is we're dealing with a dual voltage transformer. And what do transformers do for us? It steps up or steps down. And what determines if it steps up or what determines if it steps down? Well, yeah, but that's not what I was looking for. Is the load that you're running, right? What transformer you choose depends on the load. And luckily, we do have standard voltages out there. We have standard power voltages and we have standard equipment voltages, right? You understand that? So that means we can get a transformer that would probably give us just about any ratio that you need. Normally, we have two voltages over here in the good old USA. They do in Germany too. But in your house, you have two voltages available. And what are they? Yeah, 1 in 20 and 240, which is what NEC uses. It doesn't mean you have to have those. But you probably noticed that too, where you get different devices. You go look at light bulbs, they're rated at like 110, and different devices rated at, but usually it's a range. So we're dealing with a dual voltage transformer. So you got transformers all over the place. So I've got, well, that's not, that's sort of. So this is our transformer. And it shows us the windings up here. And it shows us basically a little, but transformers, by the way, we have what we call a primary and a secondary. How would you define the primary? Yeah, the load. So your primaries always point back toward the source of the power. And then your secondaries always point back toward the load. It don't mean it's necessarily connected to a load because we have, especially in our power grid, we have transformers connected to transformers, right? And so, you know, if Alabama Power is sitting over here with their smokestacks, right? And then they're going to come up here and they're going to connect to a set of transformers. Well, this right here would be the primary. And then, of course, we might step this up. And then again, this might come over to another watt. It might come over to another transformer, and then we might step it down. Well, this right here is still the primary because it's pointing to what? It's pointing toward the source. And this right here is the secondary because it's pointing toward the final load, whatever these transformers are going to end up driving. Now, the way we label these, so you go out, used to you could go to Radio Shack and buy these things. They're labeled primary and secondary. Industrial transformers are not rated primary and secondary because as long as you don't exceed the voltage of the insulation, then you can hook them up either step up or step down. So the way they're labeled high side, which would be where your high voltage is attached, and then low side, which is going to be low voltage, right? So here they label the leads with H's. Here they label the leads with X's. They don't use L's because L's were used by devices called inductors. So if you're looking at the layout of a transformer, you can look at the leads and you can tell. So when we look at our transformer, so these are labeled H1, H3, H2, H4. And then down here they're calling this X2 and XF. Now normally this would be X1 and X2, but this transformer is fused. Everybody okay there? So the X's are the low side, the H's are the high side. Now here what we're going to do is all our controls are rated at 120. We don't have 240, but let's just use that as an example. Are rated at 120 volts. We're getting 240 out of our disconnect. Actually, we're getting 208, but we'll talk about that later. So what do we want our transformer to do? Well, we want our transformer to step down. Okay. So if I was going from 120 volts and it's very popular now to use 24 volts as control voltages, then I would use a step down transformer, right? We had two robots over in the hall building that run off 440, and we don't have any 440 over there. The highest we got is 240. What do we have to do over there? We have to use step-up transformers. Everybody understand that? But normally, this guy here could either step up or he could step down. So normally what we do is transformers usually don't do this. They'll give you the voltage levels. But what you have to understand, if you understand the transformers, then you don't really have to deal with the voltage levels, especially if you're running it at voltages below what it's rated at. So our transformer is, we can wire it either to divide by 2, or we can write it divide by 4. We can wire it either way. And the way we wire it is we wire it with the primary, the H side. Everybody okay so far? So what we do is, of course, so what we're trying to do, so we got 2 coils. And what we're trying to do on this side is we're trying to get 120 volts over here for our control circuit. On this side, we can either bring in 440 or we can bring in 220. That's the way it's laid out. Of course, this is about 440 or 220. So what we do is we come over here, and this right here would be labeled H1, H2, H3, and H4. Pretty straightforward, right? And you can't renumber them. They're so what does that mean? Well, I'm always getting 220 over here, and and of course the power is set over here, right? So I is equal to P over V. Y'all understand that formula right there? Okay. So the transformer does not change the power. The transformer is going to change what? Voltage. So that means if I've got 440 and I'm delivering that power, it means my primary is going to conduct less current. If I wire it for 220, my transformer is going to conduct, my primary is going to have to conduct more current. Y'all understand that? Yes or no? Because what I'm trying to get is what? Power. So the lower the voltage, the more current. Now, people get confused with Ohm's law. They say, well, I learned it on the law. If power goes up, current goes up. If power goes down, if voltage goes up, current goes up. If voltage goes down, current goes down. But guys, you're talking about the load. We're talking about the source. Everybody understand that? So the source is trying to deliver what? Power. So the higher the voltage is, the less current required to deliver that power. Now what sets the voltage? Well, the load sets the voltage. So that means if I come over here and put 240 on a load that was designed about 120, it's going to burn it up, right? You understand? But trying to get that 120 from over here, that's what we're looking for. So how would we wire it for high voltage? So let's say I'm going to put 440. But what we want to do is, what we have a turns ratio. So they'll give you the turns ratio. So if we say we can wire this as a 2-to-1, as we can wire it as 4-to-1. Now what we mean is, on this one, every 2 turns of the primary, we have 1 turn on the secondary. This means oops, I'm sorry. I said 1 and put 4 over. For the other one says, okay, for every 4 turns of the primary, I have 1 turn of the secondary. So which one would divide by more? Well, this right here is going to give us a what? A divide by 2. This right here is going to give us a divide by 4. Everybody understand that? So what I got to do to divide by 4 is I've got to have more turns on the primary. So if I come over here and put 440 on here, do I want to wire the primary in series, or do I want to wire it in parallel? Series, because I want more turns, right? You understand? And the current is lower. So that means we need to hook what? We need to connect H2 to H3. Everybody okay? Now look, all the turns. Now we get more turns. But the current is lower, right? Now if I hook something in parallel, then the current is going to be shared between the 2 windings. So that means if this right here is 1 amp, if this is 2 amps, and this guy right here would conduct what? 1 amp, and that would conduct 1 amp. That makes sense. So if I want to get a divide by 2, then we're going to hook them in what? Parallel. Good. And you got to do this, guys. So what would I do? You can't change the numbers. So what I'm going to do is I'm going to take H1, H3, and then I'm going to take what? H2 and connect it to here. And we're going to put in, this is what you're supposed to do. Your line always comes in on what? 1 and 4. Now look, all these wires up here cross. Well, what they decided to do on the transformer, did you see how it was numbered? It goes 1, 3, 2, 4. Yeah, that's right. And this is what I tried to show y'all the other day. So what you do, if they come over here and cross this, and it makes it real easy to see if it's wired right or wired wrong, is that what they do on the transformer is they come up here and they cross these 2 right here. They're not crossed the wiring of the transformer. They're crossed when they bring the H1s and H2 leads out of the transformer. So what they do is they come up here and cross them like that. So that means if I want to wire it for low voltage, I put a jumper right here and a jumper right there, right? You understand that? If I want to wire it for high voltage, then what do? Put a jumper in the middle, good. And that means I never have any crossing wires. The wires never cross. So that means I can look and real fast if I see 2 jumpers up there. If they cross, it means it's wired wrong. If they don't cross, it means it might be wired for the wrong voltage, but it's real easy to see. So if I'm wired for low voltage, I'm going to have 2 jumpers. If I'm wired for high voltage, I'm going to have 1. So you can tell right off the bat whether the transformer is wired right or wrong. So up there on the top, if you see crossing wires, what does that mean? It's wrong. And that's why when they bring them out, they do the what? They do the H1s and H2s and H3s. They swap them around. Now, what we're going to do is all our lines, and this is what we're going to do. So this is what we're going to do today. Is first of all, we're going to play around with inside the disconnect, making measurements, seeing what voltage we actually have, and then we're going to wire our transformer, and we're going to wire it for high and low voltage. So the book's going to tell you to skip. I'm going to tell you not to skip because I want you to see the transformer actually divide. So you'll wire the primary for both high and low voltage. Are we okay? Got any questions on that? Yes or no? So what we'll do is we'll end up like this. Then we're going to finally connect our circuits up. And what we're going to do is that we have three lines. We're using three-phase. And they're called what? L1, L2, and L3. Now, what you learn real fast if you're an electrician is that you got a breaker box. How are you supposed to fill up a breaker box, by the way? So you got two, usually you have two lines, and they come down both sides. You're supposed to do what? Go here, 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 here. So every time you add a breaker, you come over to the other side. So you don't fill up the left side and then fill up the right side because you'd be overloading one side of your transformer. So what we do in here is that we figure out who's going to hook up where. You can hook it up either way. You can hook up L2 to L3. You can hook up L1 to L3. You can hook up L1 to L2. You got those different arrangements. And what we need to do is, we need to do what? We need to stagger those, right? Y'all understand? That way the whole lab is not running off of the two phases. So we'll decide how we'll hook that up. We're using 208 or ours is about 211, I think is what y'all probably measure. So let's just call it 220. And what do we want on this side? Yeah, 120. By the way, what you'll find out is that no matter how you hook it, this right here will always be equal to 220 across the two coils. So the coils are rated at 220 volts, but if you hook them high voltage or hook them low voltage, y'all understand what I'm saying? So we come over here and hook them up for high voltage. I put 440 up here. Well, these are in series. What's this going to see? This is going to see 220. This is going to see 220. If I hook them up in parallel, you can see this. It gets. Then I'm going to put 220 over here. Well, what would they both see? They both see 220. So no matter how you measure those primary coils, if it's hooked up right, you're going to see what? 220 across there. No. If the whole thing's all 220, then I wouldn't have 440. So I got to have 440. I got to have 440 right there. So how can I have 440? How can I have 220 across the whole thing when I know I got 440? So it the coils are equal, so they divide it up. You'll learn that in DC. If you got two devices, so if I come over and have two resistors, now they have to be the same size, and this is like a 1K and a 1K. You know, if I come over here and put, and they're wired in series, and I put 10 volts, and this guy here is going to drop 5 volts, that guy's there is going to drop 5 volts. So we're basically doing the same thing, but we're doing it with coils. If I come over here and put them in parallel, well, that's power right there, right? You understand? So, I mean, if I have 10 volts right there, I mean, I've got what? I've got 10 volts there and 10 volts there, so that's still basically what we're doing. So eventually this is what we're going to end up with. Now we're using what we call a ladder diagram, right? Also called a line diagram. I'll use those terms interchangeable. The book calls them line diagrams, but when you get into PLCs, they call them ladder diagrams because each rung, we call them rungs, by the way. Yeah, we're fixing that. So when we finally hook up our ladder diagram, then we're going to hook it up like this, right? So L1 is going to be the fuse side. So what are we going to use? This is going to be XF, and this over here is going to be what? X2. Everybody understand that? Huh? Because X1 is right there. But the fuse is built into the transformer. So if I look at the labeling on the transformer, it says X1 right here. And then here, I'm sorry, it says X1 right here. They call it what? XF. So notice when we look at the label on our transformer, they're called what? X2 and XF. Because it's what? It's fused. Any more questions? Okay, guys, y'all gonna need y'all's lab book. Everybody got their gloves? Because we're gonna be dealing with some high voltage. Y'all go ahead and take a break. Come back. We'll start looking at lab.